Hello Hopewell, this is Day 8 notes for Accelerated Algebra 1. Today we're going to use the AC grouping method to factor ax squared plus bx plus c. Earlier we factored x squared plus bx plus c, but what if we have a leading coefficient that doesn't factor out using a greatest common factor? More about this for today. Your goal is to factor a quadratic trinomial with three terms when it doesn't start with a 1. So the a value does not equal 1. So the warm-up says this. We're going to factor out the greatest common factor for each pair of terms. So let's take a look at number 1a. Let's decide whether it's a number, a letter, or both. Both 2x squared and 5x have an x, but there's no number that divides the 2x to the second and the 5x, so my greatest common factor will just be an x. So we're going to put the x on the outside, we're going to factor it out, and then temporarily divide or reduce the polynomial to get what's inside of the parentheses. 2x squared divided by x is 2x. Bring down the plus. 5x divided by x is just 5 because these x's are going to cancel. So your answer is x times the quantity, 2x plus 5. For the second group of terms, these do not both have x's, but both 6 and 15 divide by 3. So our GCF is 3. We're going to put a 3 underneath each. The greatest common factor goes on the outside, and then we're going to reduce the polynomial inside. 6 divided by 3 is 2. Since this was 6x divided by 3, then our answer is 2x plus 15 divided by 3 is 5. So the answer for number 1b is 3 on the outside and 2x plus 5 on the inside. So this begins our notes for today. We have a trinomial here in example 1. It has 3 terms in it. There is no GCF, and it starts with a 2x squared. So the t-chart method we learned previous to today will not work for this. If I try to make a t-chart, there are no factors of 15 that add up to make an 11 when this 2 is here. So today's method we have to use when the GCF doesn't pertain to everything and it doesn't start with a 1x squared. So if it happens, we have to use something called the AC grouping method. That's when our leading coefficient does not equal 1. So I'm going to write a does not equal 1, then we're going to use this method. Just a reminder, your a's and your b's and your c's. Your a is the coefficient of the quadratic term, your b is the coefficient of the linear term, and c is your constant value. Always the first step is to try to factor out a greatest common factor. We just did not find a number or a letter that divides all three, so we're going to skip on to the next step. Then determine the values of a, b, and c. Here our a value is 2, our b value is 11, our c value is 15. It then says, find two numbers that multiply and equal to AC and also add to be b. So in our previous lesson, we wanted two numbers that multiplied to make c and added up to make b. Today's lesson is a little different. We're going to take the value of a and the value of c and multiply these together. So a times c would be 2 times 15. In this case, our AC value is 30. That number is going to go on top of our t-chart. We also want to notice what the value of b is. So our b number goes next to that t-chart. That's our goal. Our goal is to find two numbers that multiply to make AC that also add up to make the 11 in the center. We like to go in order. So I'm going to find the two numbers that do this. I'm still on step 3, so I go in order. Let's try 1 and 30. Add them together. That makes 31. Does 2 go into 30? 2 goes in 15 times. 2 and 15 make 17. We're getting closer to 11. 3 goes into 30 10 times. Add these together, that makes 13. We're getting even closer to 11. Does 4 go into 30? No. Does 5 go into 30? Yes, it goes in 6 times. And guess what? These two numbers add up to make 11. The 11 is and represents the 11x in the center. And here's where it gets tricky. On step 4. The 11x is the term in the center. I'm going to replace the 11x in the middle of these three terms with a 5x and a 6x. So I'm going to rewrite my trinomial starting with my first term, 2x squared. Then I'm going to replace the middle term with these two terms from my t-chart. So I've added x's to the two numbers in the t-chart. So I have a 5x plus a 6x. I'm leaving a little room in the middle. And then I'm going to rewrite my last term, which is 15. So now I've split this middle term into two separate terms that in combination equal back the middle term. Okay, now this is what's really different. We call this grouping because we're going to group these four terms into pairs. So I'm going to start with the first pair and the second pair. There should always be a plus sign in the middle. The next thing I'm going to do is we're going to factor out the greatest common factor from each pair. So in this pair, the greatest common factor is, it's not a number, it's the letter x. It's a variable. X goes on the outside, and we're going to reduce the polynomial inside to 2x plus 5. Bring down the plus. What's the GCF of the second pair of terms? It's not a variable, it's just the number 3. So that 3 is going to go outside, and we have 2x plus 5 on the inside. What's happened here? After you factor out the GCF from each pair, it says check for a matching factor in each pair. So I think this is what it's referring to. The 2x plus 5 occurs twice. Then it says rewrite the factored form. Okay, it says GCF from each pair goes in one set of parentheses and the matching pair goes in the other. So to get to the last step, what we're going to do is open up two groups of parentheses. Our GCFs, the outside terms, they go together in one group. So it's an x and a 3. They go together. And our matching pair is what's the other group of terms. That's a 2x plus a 5. This should, when I multiply it back together, give me back the original. So for the final bullet down here, it says explain how you can check this. Well, we could still do another box method and multiply it back together and see if this does work. 2x times x is 2x squared. 2x times 3 is 6x. 5 times x is 5x. 5 times 3 is 15. 2x squared plus 11x plus 15 is what we started with. So the factorization of this is x plus 3 times 2x plus 5. If you don't get a matching pair, then something went wrong. So your GCFs from the outside, they go together, and your matching pair is the other group. So I think about it like this. If I ask you in this step, what multiplies a 2x plus 5? You could answer me, is it x and 3? They both multiply a 2x plus 5. The x multiplies by 2x plus 5, and so does the 3. So in this first group, x plus 3 is multiplying a 2x plus 5. On to part 2.